talking about is this. When you have exponents, you have a base and then you have an exponent. Okay? Okay, when the base is the same and you're multiplying, you add the exponents. Okay, so for example, if I had 10 to the third times 10 to the fourth power, okay, that would be equal to 10 to the 3 plus 4 power, which is 10 to the 7th. And 10 to the 7th would be your answer. Why don't you ask your question and let me answer it instead of all the people that haven't passed 8th grade yet?
Are those the only two tens or
okay. What you have is this. If I wrote this out long ways, that would be 10 to the third power times 10 to the fourth power. So how many 10s do I have? 7. So that's why it is 10 to the 7th power. Haley?
Why did you put 10 to the 4th?
Because that's what the book says. That's 10 to the third times
Oh,
10 to the fourth. Yeah, obviously.
So that's the problem in the book. Okay.
Moving on.
Why aren't you multiplying the 3 and 4?
Why am I not multiplying? Because how many 10s do I have total?
7.
Is there 12?
No.
Then that's why I don't multiply. Because instead of having, in other words, what it is, it's a shortcut. Instead of having to do this part right here, the step where we list out all the 10s and then count them up and see how many we have, instead of doing that, all we have to do is add the 3 and the 4 exponent. Okay? Now, where you're going to see it mostly is when you have things like this, x to the third times x to the 7th. That's why I use the little dot instead of the time symbol. Because then it would look like this. And then you would ask me, why did you make that one x so small? Okay. So, x to the third times x to the 7th. This only applies on multiplication. So if we put the two things together, that would give us x to the 10th power. And that's your answer. Okay. How you got that answer, once again, is you said x to the 3 plus 7 power. 3 plus 7 is 10. That's where we got x to the 10th power. Oh, I'm so glad. I'll be able to have a good Thanksgiving knowing that. Now, remember, please let the person who's passed 8th grade answer the questions. Copeland, do you have a question or you're serving somebody? I mean, you're sitting there like this. So I thought maybe you had an imaginary tray on your hand and you were going to serve hors d'oeuvres. Hors d'oeuvres. No, hors d'oeuvres. I was saying it like a Texan. Hors d'oeuvres. All right.
Wait, are you just adding all the extra? You have to. Oh, it's of course.
You had a question? Oh, okay.
What about? Why were you just standing there?
Have I said anything about division yet? Then don't ask questions about division. Oh, are you talking about 28? I thought you pointed at 32. Okay, I'll handle that in a second. Hey. All right, now, if you have this, three x to the second times 5x to the sixth. Now, we have a property that we've talked about for the last 3 years, and we call it the commutative property. Okay? Please understand that this problem I'm fixing to write is an equivalent problem to what we already have in 3x to the second times 5x to the sixth. This right here okay, those are exactly the same. Okay, we can use the commutative property right here, and we can do this. We can do that right there. 3 times 5 times x to the second times x to the sixth. We can rearrange the terms or the factors. We can rearrange the factors in a different order, and it doesn't change the answer. Now, I can take and put these two together, 3 times 5, which is 15, and I can put these two together. When I put those two together, give me x to the 8th power. Huh? Hush. So why are you making fun of your question?
I don't know, I just wanted to say that.
Oh, well, I'm glad you got that out of you, Josh.
I'm not Josh.
Well, you're acting like him. Next thing you want to do is get up and run around the room. All right. We have z to the 5th times z to the 2nd times z to the 7th. Okay, all the bases are the same. Remember, the bases have to be the same before we can put them together. So we have z to the 5th times z to the 2nd times z to the 7th. Those are all z's, so I can put and just add. We have z to the 5 plus 2 plus 7 power.
14.
And that gives us 14. So z to the 14th power. Okay?
Yes, sir.
Now, it gets a little bit more difficult when we have this, x to the 2nd times y to the 3rd, y to the 4th, times x to the 3rd. X to the 2nd times y to the 4th times x to the 3rd. Now, in this problem, we have Gracie. In this problem, we have two different bases. We have the x that represents those two factors, and we have the y that represents that factor. Now, we can use the commutative property, okay? We can use the commutative property and rearrange the terms. Okay, I can put these two terms together, x to the 5th times y to the 4th. I can't put the x and the y together, but I can do this. And you have the correct answer. Okay, so that's how you would put that one together. No, because when you have a number next to a variable, or you have two variables next to each other, it means to multiply. You don't have to put the sign in there.
Okay, so you didn't add, why didn't you add those?
Huh?
Why didn't you add those? Anthony! What the heck?
Do what?
Why didn't you add those?
Why did I add what?
Why didn't you add those?
What?
5 and 4.
Because one is an x and one is a 5. I mean, one is a y.
She was like, no. Why didn't you add 5 and 4?
I just told you. Because one is, I need you to be quiet.
I can't hear him.
Because one is an x and one is a y. The bases are not the same. The base, the big number, has to be the same to put the exponents together. That would be like you doing this, saying that 3 to the 3rd and 4 to the 2nd is 3 to the 5th. How's that possible? It's not. You can't put those two things together. You can't put that together because you have a 3 and a 4. They have to be the same before you can put them together. Sorry, I thought I said that when I said one's x, one's y. All right, now. All right, we have p to the 3rd times q to the 2nd in parentheses times p to the 4th times q to the 2nd in parentheses. Now, just as I stated on the previous problem, this problem is the same as this. Those two problems are equivalent. Because here, where there is no sign in between the P and the Q, means to multiply. Where there's no sign here in the P and the Q, means to multiply. So now I can treat them as 4 different factors. Then I can take and use the commutative property and rearrange those factors. So you have that. Now I can actually simplify that down where I have p to the 7th power times q to the 4th power. And you put those together and you have p to the 7th times q to the 4th, or q to the 4th. Okay, open your books to page 197. We're not done yet. I'm going to let you do a couple of problems, and then I want to check them. Underneath that card over there. Okay, on page 197, I want you to do 26 and 27. And I want you to do 47 and 48. Look at the screen. do those problems. I'll give you a couple of minutes, and then we'll discuss them. All right. As we see these four problems, okay? First one here, that's the same thing as that right there, and therefore we can put the W's together, and that gives you 3W to the 5th. I don't need the comments, noise. Next one, we can rearrange this one where it's z to the 7th times z to the 4th times 8. And then put the z to the 7th, z to the 4th together, and that gives me 8z to the 11th. Remember that the constant or the number must go in front of the variable, not after the variable. It's not mathematically wrong, it's just not accepted practice. The next one, this problem, four times m to the 4th times n to the 7th times m. Okay, I can rearrange those terms using the commutative property. Make it look like that. Now the thing that some people forget is there is a 1 right there. So that would give me 4m to the 5th n to the 7th. Right here, that expression is m times m times m times m times m. Okay, this represents 4 m's, and I have 1, 2, 3, 4, 5 m's. That's why it's m to the 5th, because there's 5 m's. Okay, go up there in the screen and count them. I just numbered them. 1, 2, 3, 4, and 5. M to the 4th means m to the 4th means I am taking an m and multiplying it by itself 4 times. Just like 2 to the 4th power is 2 times 2 times 2 times 2. 4 2's. M to the 4th power is m times m times m times m. Then I multiply it by another m. So there's 5 total m's in that problem. That's why it's m to the 5th power. Just like this, if I had m times m, what is m times m? M to the 2nd power, because there's 2 m's. Okay? So that's one that usually either confuses some people or they lose track of and do it wrong on a test. So make sure you get that one right. So the last one is 4 times a times b times 5 times a squared times b to the 3rd. I can rearrange it and go 4 times 5 times a to the 2nd times b to the 3rd. Now the 4 times 5 is 20 times a to the 3rd times b to the 4th, which is 20 a to the 3rd b to the 4th. Okay, and that is your 4 answers. 3w to the 5th, 8z to the 11th, 4m to the 5th, n to the 7th, and 20a to the 3rd, b to the 4th. Anybody get all 4 of them right? Okay. Let me rephrase my question in English. Did anybody get all 4 right? So the answer to that would be no. Thank you. No, yeah, but I got no, I didn't, but yeah, I did. I got 3 right. All right, now let's talk about division. Okay, now approach it from that crossing out standpoint. It's going to do it from the. Yeah. All right. Division. All right, when the base is the same, when the bases are the same would be the correct English. And you're dividing, you will subtract the exponents. So, for example, 8 to the 12th power over 8 to the 6th power. Okay? Are the bases the same? Yes. So that would mean I would take 8 and take 12 minus 6. Okay, 12 minus 6 is 6, so that would be 8 to the 6th power. Okay, now let me prove that to you with the variable one. Okay, x to the 4th over x. Okay, this is x to the 4th minus 1 power, which is x to the 3rd. Now, if we prove that mathematically, x to the 4th would be that right there. X would be that right there. The x's cancel out, leaving me with 3 x's on top, so it is x to the 3rd. Okay, that's how we can do that. Let's say we had y to the 9th over y to the 3rd. Okay, that would be y to the 9 minus 3 power, which is y to the 6th. Yeah, it's y to the 3rd. Now, let's say I had something like this. Let's say I had 6x to the 3rd power over 14x. Okay. The first thing we're going to do is to understand that those two problems are equivalent. Okay? Because that's what 6x to the third means, 6 times x to the third. So that means I can do this. Okay, that is an equivalent expression. Now, to write this out in long form, 2 times 3 would be equal to 6, correct? Okay. Times x times x times x. On bottom, I have 2 times 7 times x. Now I can cancel those two, leaving me with 3x to the second on top and 7 on bottom. Okay, and really what you're doing is this. That problem is 6 over 14, and you're dividing by 2 over 2. And that goes to 3/7 times this problem is x to the 3 minus 1 power, which is x to the second on top. And that's how we're getting 3x to the second over 7. Okay? All right, for homework, you don't have to do anything.
Yay! I'm going to forget all this over the break, though.
That's okay, because you're going to forget it by the time you get to the next class. Huh? It's me. You may go.